Hey everyone, welcome to our next video. This section is going to be on 2.2, which is just more graphing. Go ahead and write it down. So 2.2 is the general sine wave. In this section, we're going to learn about graphing sine and cosine, when the b value is not equal to 1. So something, to remind you a little bit, I'll come back up here. Remember that your general form that we're always looking at is this right here. And it could either be cosine or sine. All the other letters are in the same spots. But we haven't done any yet in 2.1 where the b value is not 1. So now we're going to do some like that in this section. Now, some of the nice stuff is that nothing actually changes at all from what we usually do. I would like to make a little bit of a comment though. So there's a little bit of a difference here from how I do this section and then from like how the textbook teaches this section, which means there's a little bit of a difference in the My Math Lab. So here's my little comment here. We see our general form like this. I'm just going to put sine right here, but it could be sine or cosine. So this is our general form. I want to remind you that I told you that the phase shift is C over B. Now, in my math lab, if you look at their examples and stuff, this is what they're going to show you. They're going to tell you to actually factor out the B value, which will leave this as x minus C over B plus D. So this C over B is their phase shift. The reason I don't like to teach it this way is I just find that students often forget to factor out the B. So I just say, let's just do it as C over B. That way, it's just a little bit less for you to remember. You don't have to remember the factoring out step. But I do just want to show you that if you go through the examples and stuff on my math lab, they may do it like this, and you might feel a little confused. So just something to be aware of. I do not like to factor out the B. I just like to treat the letters where they are and just find C over B that way. So I'm just going to kind of jump right into an example. I'll say graph one cycle. Find the period, any transformations, any transformations, and we'll also find the range. And I'm going to make sure I put on here, clearly label 5 points. And we'll do a few of these. So let me start off with maybe a sine one. So we'll do 2 sine. Let's do 3x plus pi and minus 1. So this one's got everything. It's got an a value, it's got a b value, it's got a c value, it's got a d value. The nice thing is I'm not going to actually do anything different from how I showed how to find the values of x and y in 2.1. I'm doing the same stuff. The only thing that's different is that now we have a b value to work with. So I'll put my graph over here. Hopefully that looks all right. And so I always like to start with finding our like transformations and stuff. So first it asks for the period. Now I usually write this out for you, like kind of what I'm looking for. Like on the test, I'll put like period, phase shift, amplitude, vertical shift. So I'll write all of that for you, and then you'll just kind of tell me next to it what it is. So for the period, remember that period is 2 pi over b. Sometimes maybe it'll be helpful to like label what your A, B, C, and D are. So our A value here is 2, my B value is 3, my C value, be careful here, it's actually negative pi, and my D value is negative 1. The reason it's negative is because what this really says is 3x minus negative pi, and those negatives are canceling out to show us a positive. So be careful there. So this is going to come out to 2 pi over 3. My phase shift is C over B. So in this case, it's going to be negative pi over 3. So that also means that when I find my x values, the first x value I get should be negative pi over 3. Amplitude is my A value. It's also the absolute value of A. So if A was like negative or something, that would not be the amplitude. The positive version would be the amplitude. But this is just going to be 2. And then the vertical shift is negative 1. I usually like to make a point here for the phase shift. If it's negative, that means it's going to move to the left. And then if a vertical shift is negative, that means it's going to move down. So now I'm going to go through the process of finding my x values. I'm going to draw a little line here just so we don't get too caught up. So I have my x values. And I'm going to find them the same way that I did in 2.1. So what I like to do is I like to take my parentheses and set it equal to what I call the big 5, which is 0, pi over 2, pi, 3 pi over 2, and 2 pi. Now again, the reason I do that is because the original graph goes through all of those points. So what I'm trying to figure out is what is this 3 doing and what is this pi doing that's going to change these x's from their original. Now I'm going to solve these for x. So first I'm going to subtract pi from both sides. So I subtract pi first. So now this is going to leave me as 3x equals negative pi. And then please remember that whenever you are putting fractions together, you need denominators the same. Oop, didn't mean to erase. So this is going to be 2 pi over 2. If I do pi over 2 minus 2 pi over 2, I get negative pi over 2. Next, I get 3x equals 0. Next, I'm going to make this 2 pi over 2 so that the denominators are the same. I get 3x equals pi over 2. And then lastly, I get 3x equals pi. Now, hopefully you can see kind of a pattern there. Got to keep solving for x, so now I need to divide by 3. Now please remember that when you divide by something, that is the same as multiplying by the reciprocal. So for these ones that have fractions, instead of saying divided by 3 and making a complex fraction, I'm just going to say times 1/3. So this leaves me with x equals negative pi over 3, x equals negative pi over 6, x equals 0, x equals pi over 6, and lastly, x equals pi over 3. So these are my x values. Next up, I'm going to find my y values. So remember in 2.1, I said that there are multiple ways you can find your y values. If you want to literally just plug in these x's into the parentheses, you are totally welcome to do that. You can also skip a little bit of steps here. So I am going to skip some steps. If you need to show more work, then I would go back to 2.1 and look at how I did the y values there. I can scroll up real quick. So if you look at these, go back to this video, I actually plugged in the x value that we found into the original equation and just showed all those steps for finding the y. Here, I'm going to skip a little bit of steps. So I know that sine goes through these certain points. So the original sine graph goes through, let's think about it. So remember your general shape. So the general shape of sine looks something like this, right? Or you can also remember the coordinate plane. So this is 1, 0, this is 0, 1, this is negative 1, 0, and this down here is 0, negative 1. So I'm writing pretty small, but it's just a little reference. And remember, sine is always the y values. So it starts at 0 and it works all the way around. So I've got 0, 1, 0, negative 1, 0. And that makes sense here. So the middle would go through 0, then the top would go to 1, and the bottom would go to negative 1. And then, so I'm just seeing what the 2 and what the negative 1 are going to do to our y values. And now I'm going to simplify. So I get 2 times 0 minus 1, negative 1. 2 times 1 minus 1 is 1. 2 times 0, 0 minus 1, negative 1. 2 times negative 1 is negative 2, minus 1, negative 3. And 0 minus 1, so negative 1. Now, I usually like to give you a little table to put your x and y values in, just so it can be really neat. So in this case, I'm going to go ahead and write all of those in. So I have negative pi over 3, negative 1, negative pi over 6, 1, 0, negative 1, pi over 6, negative 3, and pi over 3, negative 1. So I'm just matching up x and then my y value that I found. I'm going to go plot these. Since I have 2 that are negative, that means I'm going to have 2 on the left side. So I have negative pi over 3, negative pi over 6, 0, pi over 6, pi over 3. And now when you do this method, remember that you're always going to find your x values in order from least to greatest. And then I'm just equally spacing them as best as I can. For my y values, I go up to positive 1, and I go down to negative 3. So I've got 1, then 1, 2, 3. And now I'll go ahead and draw in my shape. So I've got, well, plot my points and then I'll do my shape. So negative pi over 3, negative 1, so that's here. Negative pi over 6, 1 is up here. 0, negative 1 here. Pi over 6, negative 3 is down here. And then pi over 3, negative 1 is over here. And there's my general shape that I see. And so remember that sine will always look like this. So if you somehow plot your points and they are not looking like this, there's definitely something wrong. Now, I do want to talk a little bit about how I do the points for a question like this. I'm going to grade, the period, the phase shift, the amplitude, the vertical shift. I'll give you probably about half a point or so for each of those. I think I usually do 2 for the x's, 2 for the y's. I also like to give a point for just the general shape of sine. So let's say that you don't know how to do anything, like maybe you can get the transformations, but you don't know how to do the x's, you don't know how to do the y's. At least show me that you know what the wave looks like, and I can maybe give you like a point or something for that. But all of it, it really is supposed to work together. So I think it's great to have an understanding of the transformations and knowing how to solve the points. So I want to talk a little bit about that. With your y values, if we see how, let me use like a color to write with. So negative 1 here is our vertical shift. That's why the middle of our graph goes through negative 1. So I've had some people who kind of just do the y values in their head, and they just say, okay, the middle should go through negative 1 because that's my vertical shift. So they plot those points. Then my amplitude is 2. So that means that the peaks here should go up and down by a factor of 2 from the middle. So what I mean by that is negative 1 to positive 1 is 2. Negative 1 to negative 3 is 2. So we should see those transformations happen like while we graph. And it can just kind of help you have a full understanding. And I can't really stress this enough. I mean, I've had people who just kind of can graph trig functions without showing very much work. It's okay if you are like that. I think especially with the y values, it's totally possible to not show much work for those, especially if you know what the general shape is supposed to look like. You may just be able to use transformations. I just want to say to be careful not showing much work, because the less work you show, the less partial credit I can give. So if you don't really show me anything, all you've got is a graph and it's wrong, I can't really do anything with that. But if I say, oh, their x values, they just forgot to divide by 3, right? I can definitely give more partial for something like that. So just keep that in mind while you're doing these. Also, I recommend whenever you do these in the homework, you should graph them by hand first, kind of like how I do in class. And then you can put in like your points into my math lab and put in the graph and stuff. Because when you put in the graph, they just make you type in the transformations and that's it. It's not very good. But that was actually a pretty hard one. Let's do another one. So now I'm going to do a cosine one so that we have some experience with both. So let's do y equals, let me throw in maybe a negative in here just to see what happens. I'm going to let's do pi over 2x. I'll put my graph over here. So I'm going to write everything out that I need. So I'm going to ask you for the period, the phase shift, the amplitude, and the vertical shift. I am abbreviating a little bit here. And I always like to label my A, B, C, and D. I just find it helpful. So my A in this case, be careful, it's still just 2. There is no, like, you don't ever put negative whenever you're talking about like what your actual amplitude is. You can put negative here for the A value. Just be careful when you write it in as your amplitude. B is pi over 2. I don't have a C and I don't have a D. So my period is 2 pi over B. So 2 pi over 2. Now remember that when you divide, that's the same as multiplying by the reciprocal. So this is 2 pi times 2 over pi. So this is going to cancel out to 4 because the pi's cancel. My phase shift is C over B. I have none, right? I have no C value. So that means that I'm not going to have any kind of phase shift. My amplitude is 2, not negative 2, just 2. My vertical shift, I don't have a D value, so it's none. Now there is one more transformation that happens. This negative in the front, what it's going to make happen is there's going to be a flip. So we're going to flip upside down. And just as a little like maybe side thing here, if you remember anything about like in algebra, like doing parabolas and stuff, if you have like negative 2x squared plus 3x plus 4, I'm just writing something. Anytime that a value in front is negative, that means that your parabola faces downwards. So that's kind of what we're going to see here is that if you have a negative in the very front, in front of your a value, your whole graph just flips. So what this is going to mean is that our original cosine graph looks like this. We're going to see it be opposite of that. So we're going to see something more like this when we graph. Let's go ahead and do my x values. Again, I'm going to do it all the same. So I have pi over 2x equals 0. Pi over 2x equals pi over 2. Pi over 2x equals pi. Pi over 2x equals 3 pi over 2. And pi over 2x equals 2 pi. And then I solve for x. So I'm going to use the multiplying by reciprocal idea. So I'm going to multiply. There's just so many different ways you can think about it, but if you divide by pi over 2, you can write it that way, or you can use the reciprocal. Anytime I'm dealing with fractions, I like to use a reciprocal. So I'm going to multiply by 2 over pi on both sides. That's going to cancel this out. I just don't really like to have complex fractions. So that's why I do it this way. And just writing all that in. So all that cancels. I'll be left with x equals 0. That makes sense because we didn't have a phase shift. So the x will still start at 0, just like with the original graph, because we didn't move left or right. So the starting point is the same, but because the period has changed, we do see the other x values change. This next one is going to cancel out to 1. Next, I get 2. Next, I get 3. And lastly, I get 4. And I know this one might look weird to you, but it's fine. So we've got 0, 1, 2, 3, 4 as my x values. Now I'll go and do my y values. So again, my y's, I am going to skip a little bit of steps here. I'm just going to use my amplitude, and then if I had a vertical shift, I would have it out right here, but I don't have anything. And instead of in the place of the cosine part of this, I'm going to write the original points that cosine goes through. So if we need a reference to think back on that, remember that cosine in the original unit circle goes through the x values. So that's going to be 1, 0, -1, 0, back to 1. 1, 0, -1, 0, 1. And then I'm going to simplify this, so I get -2, 0, 2, 0, -2. So my highest value is 2, my lowest value is -2. And so I'll put my graph on here. So I've got, oh, let me go ahead and, I do always like to rewrite the xy values in a little table. So I've got 0, -2, 1, 0, 2, 2, 3, 0, and 4, -2. So 0, -2 is here. 1, 0, 2, 2, 3, 0, and 4, -2. So here's my shape, and we're good. Now again, I did mention this last time in our last video. Make sure that you don't go above these min and maximum points. Make sure you don't draw your graph above or below those whenever you draw in your curve. Okay. And I just want to point out some things. So we did not have a vertical shift, so the middle of our graph goes through 0. And then my amplitude being 2 means that I went up by 2, and then I also went down by 2 for the min and maxes. Now I did realize that I forgot to write the range on part A. I'll go back and do that real quick, but let's do it for this one first. So the range for this is going to be -2 to 2. So the range is just always the lowest value, y value, comma, the highest y value. I'll scroll up to part A real quick and we'll write it for that one. So my range here was -3 to +1. And it's always in brackets since the graph really does touch those points. Another thing I want to point out about the period, I believe I talked about this in 2.1. Your period is where one cycle appears, so it's referring to the x values. So if you were to take your last x value minus your first x value, you should get your period. So that's one way to kind of check yourself. Either, like, if it doesn't work out that way, like if you take your x values and you subtract your biggest one minus your smallest one, if it doesn't equal your period, either there's something wrong with the x values or there's something wrong with your period. Now when we come down to part B, we can check it as well. So my last x value is 4, first x value is 0. If I subtract that, I get 4, and 4 is also my period. So it makes sense. Like it checks out. All right. So I'm trying to think if maybe we need any more of these at all. Maybe I'll do like 1 or 2 more. I mean, the content of what I'm doing doesn't change. It just changes like the actual example. Like my process is not changing no matter what. I guess we should do maybe another sine, maybe another cosine, maybe one more of each. Maybe would be good. So let's see, I'll do y equals sorry, I'm just kind of making one. I like to change them at least a little bit, but to be honest with you, there's not much that could change. I'll do another b value in here, 2x. Let's do minus pi over 2, and let's actually do an amplitude. So let's do 3 as my amplitude. So as always, I'm going to ask for the period, the phase shift, the amplitude, and the vertical shift. And I'll put my graph over here. I like to label, so my A value is 3, my B value is 2, my C value is pi over 2, and my D value is 0. I don't have one. My period is 2 pi over B, so that's going to be 2 pi over 2, so pi. My phase shift is C over B, so pi over 2 over 2, which is the same as pi over 2 times 1/2, so it's going to be pi over 4. My amplitude is 3, and my vertical shift is none. Also, since my phase shift is positive, I am going to move to the right. So that means I'm going to only be on this side of the graph. Finding my x values. So I take the inside of my parentheses, set it equal to the big 5. Okay. I'm solving for x, so I'm going to add pi over 2 to both sides. And that's going to cancel it out over here. Simplify, this is going to give me 2x equals pi over 2. 2x equals 2 pi over 2. Next, I'm going to write that pi as 2 pi over 2. So that's going to give me 3 pi over 2. Next, I get 4 pi over 2. And lastly, 2 pi can be written as 4 pi over 2. So this one's going to be 5 pi over 2. And I can definitely see a pattern. So that's a good thing. If I'm not seeing any kind of pattern, there could be something wrong. It could just be harder to see the pattern, but it is something you should check out for. Next, I'm going to divide by 2. Remember, dividing by 2 is the same as multiplying by a half. So if you want to think about it that way, that works as well. So let's see, I get x equals, it's going to be pi over 4. Well, that's good because that's also my phase shift. Next, I get 2 pi over 4. So that is going to simplify to pi over 2. I don't mind if you don't reduce it, but keep in mind that my math lab will ask you to. This is 2 pi over 4, which is also pi over 2. Next, I get 3 pi over 4. Next, I get 4 pi over 4, which I can just write as pi. And then lastly, I get 5 pi over 4, and that one will just stay the same. So these are my x values that I'll go plot. I'm trying to just equally space them. I do need a little bit more room here. So 5 pi over 4. And now let's do my y values. So for my y values, I like to just remember the original points that sine goes through. So my 3 is the only thing that's outside of like the sine part of it. If I had a vertical shift, I would have that right here, like if it was -1 or +1 or whatever it was, but I don't have anything. So in these parentheses, I'm going to write the original points that sine goes through. So as always, I'm getting these from the original unit circle. And sine is always the y value, so 0, 1, 0, -1, back to 0. Simplify, I'm going to get 0, 3, 0, -3, 0. Excuse me. So my graph goes up to 3, down to -3. Now I'm going to plot my graph. Oh, I always forget to do this part. I like to write down my XY points. Again, I'm going to write you like a table on the test that you can put everything in. I'll probably show you like exactly what it'll look like on the test for kind of the review video that I'll do. Just so you'll know exactly like how it's going to look and everything. So let's go ahead and plot these on here. So I've got 0, then I go up to 3, back to 0, down to -3, back up to 0. So there's my graph. And I do know that the original sine graph looks like that, so that definitely helps as well. Now something that I can bring up here is if I had done cosine here instead of sine, the only thing that would have changed is these values right in here, because I'd have had to put in the cosine values, not the sine values. And of course, the general shape of the graph would have changed. The range would not change. In this case, our range is -3 to +3. That would still be the same. It's just the actual points, the y values would be different. Everything else would be exactly the same. So I actually want to show you that. So let's go ahead and do the next one. I'll just do part D. Let's do y equals 3 cosine 2x minus pi over 2. Or maybe I could change it a little bit. Maybe I could change it to maybe like a plus pi over 2. Let's do that. I do want to do it a little different so that you can see some things change, but if I had left it as the minus though, literally the only thing that would have changed is the y values. X values have been exactly the same, all the period, phase shift, all of that would have been the same. But this one I'll just change a little bit. I'll basically show you what changing the phase shift does. So I'm going to ask for the period, the amplitude, the phase shift, and the vertical shift. So my A value here is 3, B is 2, C is pi over 2, negative, and D is 0, none. Period would be 2 pi over 2, so that's going to be just pi, so that's the same. Amplitude is going to be A, so that's just 3. Phase shift is the only thing that changes a little, so it's negative pi over 2 over 2, so that's going to become negative pi over 4. My vertical shift, I've got none. So let's go get these x values. Process is the same. I'm going to take the inside of these parentheses, set it equal to the big 5. And now I'm going to solve for x. So first I will subtract pi over 2 from both sides. And that leaves me with 2x equals negative pi over 2. The next one would be 2x equals 0. 2x equals, this one would be pi over 2. 2x equals 2 pi over 2, which we could simplify to pi if you want. And then 2x equals, this would be 4 pi over 2. So minus pi over 2 will be 3 pi over 2. So I definitely see a pattern, which is great. Next, I divide by 2 or multiply by 1/2, depending on how you want to view it. So next, I get x equals negative pi over 4, matches my phase shift, so great. x equals 0, x equals pi over 4, x equals 2 pi over 4, which I can write as pi over 2, and lastly 3 pi over 4. So there's my x's. I can go put those on my graph. Since my phase shift technically went to the left, I am going to have to start on the left side. And I have a negative value, so negative pi over 4, 0, pi over 4, pi over 2, and then 3 pi over 4. My y values, I just have to take the 3 because I don't have a d value to use. The original cosine graph goes through 1, 0, negative 1, 0, 1. I get those from the original unit circle. Scroll up real quick. It's the x values here. That's what I just got. Simplify, I get 3, 0, negative 3, 0, 3. So you'll see because I didn't change my a or my d, the range and stuff didn't change. It's just that my actual points changed because I changed from sine to cosine. So let's see, this one goes up to negative 3, up to positive 3, down to negative 3. So I get 3, 0, negative 3, 0, positive 3. And I'm just looking for a sketch. It doesn't have to be amazing, but I feel like that's pretty good. Might look a little lopsided, but that's okay. And I will have a table for you to actually write all of these points into. So we can do that. Okay. Now I kind of want to show you one more way to maybe get the x values in case you don't like this way that I've shown. You can use what is called the midpoint method. I like it and don't like it at the same time. So I'm going to show it to you in this video, but I just want to make a comment that the issue I have with the midpoint method is that it relies on transformations. So let's say that you get the period wrong and then you use this method, all of your x values are going to be wrong. If you have well, that's really the biggest part of it, honestly, it's just the period. But it really relies on that. So it's very important that you have the period correct if you're going to use this method. I like the method that we've been using because you can check your period. So I can take the last value minus the first value. If I subtract those, I'll get my period. So it's almost a way to check myself. Whereas with the midpoint method, you're going to use the period to actually find the x values. So if the period is wrong, your x values are also going to be wrong. Now, I do grade based on follow through. So you would probably only lose points for the period, and I wouldn't take off for the actual x values. Because if you found the x values correctly, then I'd be like, okay, good. It's just the period was messed up. So it's not like you would actually be deducted much from me, but it could create issues while you're, trying out problems. So I just want to show you another method. So another method for finding x values. So this is called the midpoint method. And you can use this as well, if you ever need more in between points, you could always use this method. And I'll show you what I mean by that. So I'm actually just going to do the same problem that we just did. So 3 cosine, what was it? 2x plus pi over 2. And so all I'm going to show is just another way of showing the x values. I'm still going to write the period and stuff because I do need it. So the period for this one was 2 pi over 2, so that's going to be pi. I also want my phase shift, so that's going to be pi over 2 divided by 2, so pi over 4, and it is negative. So here's how it goes. I'm going to do it over here. Your first x value is whatever the phase shift is. So your first x value is your phase shift. So in this case, our first value is negative pi over 4. Then we actually find our last x value. So my last x value you find by taking your first x value and adding the period. So first x and then add the period. So in this case, we're going to take negative pi over 4 and we're going to add pi to that. So this is negative pi over 4 plus 4 pi over 4, which brings us to 3 pi over 4. Now you find the middle of these 2 points. So to find the middle of something, you add them together and then divide by 2. So if I do negative pi over 4 plus 3 pi over 4, and then divide it by 2, that'll give me my middle point. So then in this case, this will be 2 pi over 4 times 1/2. So that's going to be pi over 4. Then you take the middle of your first and your third one to get your second. So I would do negative pi over 4 plus pi over 4 divide by 2. That's going to give me 0. And then to get my fourth one, you do the middle of your third and your fifth. So in this case, that would be pi over 4 plus 3 pi over 4 divided by 2. So this is 4 pi over 4 times 1/2, so pi over 2. So these are the same x values that we got earlier. It's just we found them in a different way. Now I do like this method a little bit. Actually, when we learn how to graph tangent, we'll use this method to help us because there may be times where maybe you need extra points in between points that you've already found. And so I do like the midpoint method for that. And so what this one really is it's just finding the middle of your points to get more points. The issues that I have with it is that if your phase shift is wrong, then it's wrong. And then if your period is wrong, then it's wrong. So that's kind of my issues with it. It's just that it relies on you getting those right to begin with. Whereas the other method, if you have those wrong, you can still get the x values correct, and then you might be able to actually realize that they're wrong because they don't match the x values. So it's just something to kind of keep in mind while you're doing these problems. I like this method. I actually do think it's a little bit simpler on maybe the actual arithmetic, in my opinion. But yeah, and we will use it a little bit for tangent. So it's not going to completely go away or anything. So it is something for sure to take a look at. But if you prefer the other method, then by all means, you can keep doing that for at least sine and cosine. It'll probably be a little easier to grasp whenever we do tangent because of what we use it for. Like, I don't know. It's hard to explain. It's hard to explain without like actually showing you stuff, and I'm not doing that yet. So, okay, so I think that is it for this video. Our next ones is going to be 2.3, and that's secant and cosecant. That one's actually really short. And then our video after that is going to be 2.4, which is graphing tangent and cotangent. So I will see y'all in our next video. I will also do like a review for test 1 video. So a few more videos to come. And remember that your test is coming up. I'll see you in the next one. Bye-bye. Have a good day.